Hi everybody, today we are going to talk about arithmetic sequences and partial sums. So an arithmetic sequence is simply a sequence where the difference between the consecutive terms is constant. That's kind of a fancy way of saying that you're adding or subtracting the same number each time. So there is a formula that we can use to find an arithmetic sequence. We need to know two things to make this formula. We need to know a sub 1 and d, which is that common difference, whatever you're adding or subtracting. So the formula is a sub n equals a sub 1 plus n minus 1 times d. Now you'll also see that once you're familiar with these types of sequences, we can use little shortcuts, but this formula should always work. So here's a really basic example just so we can see what the formula looks like. It says, write the formula for the nth term of the arithmetic sequence whose common difference is 3, that's our d value, and first term is 2. So we're really just substituting values. So a sub 1 is 2 plus n minus 1 times d, which is 3. And then from there, we're just going to distribute in combined like terms. So very straightforward. Now, let's try one that is a little bit trickier because if you remember, we need two things. We need a sub 1 and we need d. But in this case, we are given neither of those things. But what we are given is two of your terms. We're told that the fourth term is 20 and that the 13th term is 65. So there's two different ways to approach this problem. So one way you can do this is by setting up a system of equations to help us find a sub 1 and d. And luckily we are given two terms, so we can create two equations. So using the fact that the fourth term is 20, I can substitute that. So a sub n is 20. The term is 20, and n is 4. So 4 minus 1 times d. And I'll just simplify that really quick. So there's one equation. And we're going to do the same thing with the fact that the 13th term is 65. So we can say 65, which is the term, equals a sub 1 plus n, which is 13 minus 1 times d. So 65 equals a sub 1 plus 12d. So now you can see we have a very simple system of two equations. You can solve it however you want. You can use substitution, elimination. You can even go and create a matrix if you want to solve this. For me, I'm going to use elimination method. So I'm going to put the opposite of that first equation underneath. And then add vertically. So 48 equals 9d. So d equals 5, which then I can go substitute right up here. And I can see that a sub 1 is also 5, 20 minus 15. Now that I know the two things that we need to make the equation, I can just go back and plug it into our little formula. So a sub n equals 5 plus n minus 1 times 5. So we just get 5n. Now there is a different way you can start this. We can kind of use the fact that we know that it's arithmetic. We have to be told that, but we're assuming everything we do today is arithmetic. And we know that, well, from the fourth term to the 13th term, there are kind of 9 jumps in between. And each of those steps, each of those terms in between, we're just going to be adding our d value. So I know that if I start at the 14th term, and then I add 9 times whatever our d value is, I add that d value 9 times, I will reach the 13th term, whatever that is. But luckily, oops, I'm sorry, this should say a sub 4, not 14. There we go. We know that the fourth term is 20, so if I start at 20 and I add our common difference 9 times, I should reach our 13th term, which is 65. So you get that same thing, and you get that same d value. But from there, you still have to find a sub 1. So you'd have to either kind of count backwards from a sub 4, which is not always very efficient, or you can plug it in here to find a sub 1. So this is just a different way to approach that problem, or at least to get a good start. Either way is fine with me. All right, go ahead and pause the video and give this one a try. Okay, so here I use systems of equations, and I used elimination to solve. And you should end up with a sub 1 being -3. Your common difference is 4, so your rule is 4n minus 7. Quickly, we're going to practice writing a recursive rule. It's very, very straightforward. Here we're given an arithmetic sequence whose first two terms are 2 and then 7. So I can see that from 2 to 7, I'm just adding 7. So it's essentially saying take the term before and add 7. So we can really quickly write that actually as recursive. A sub n minus 1 is the term before, and then you add 7. The only thing to remember about recursive is you do need to define that first term. Now, while it can be really, really quick and easy to write a recursive formula, it's not always as useful, because what if I asked you to find the 125th term? Well, to find the 125th term, I need the 124th term. And to find the 124th term, I need the 123rd term. So you can probably see where I'm going with this. It's not always the most efficient way to find a term later on, but it is a good thing to know. However, unless I specifically ask to write for you to write a recursive formula, I would like you to write just a normal sequence formula. I still would like you to practice this one time, so go ahead and pause the video and see if you can write a recursive formula for this sequence. So here you go, you're essentially taking the term before and adding 8, but just make sure you have defined your first term. Okay, so now we're going to talk about the sum of a finite arithmetic series. So it's essentially taking those terms in the sequence and adding them up, turning it into a series. Note that we're only working with a finite arithmetic series because there will never, ever, ever be a sum for an infinite arithmetic series. We will find or discover that there are certain types of series that do have infinite series that have sums, but arithmetic series are not one of them. So there is a nice little formula for this. So it's the sum of the first n terms. It's like an nth partial sum. So it's the sum of the first n terms equals n over 2 times the sum of your first term and your nth term, which means that you do have to know these three things. So the formula is pretty easy to use, but remember, it's for the first nth term. It's for the nth partial sum. So what if you wanted to do the sum of the 20th through the 30th terms? So strategically, I just want you to understand, it's still possible to do with this formula. We would just have to start by finding the sum of the first 30 terms and then subtracting the sum of the first 19 terms, leaving you 20 through 30. So just keep in mind that it is possible to find a specific sum that doesn't start at 1, but you will have to do 2 separate formulas for it. All right, let's give this one a try. So here I would like you to find the sum of the first 150 terms, so the 150th partial sum of this sequence, this arithmetic sequence. So I know that according to our formula, there's 3 things that we need. We need to know n, which we know is 150. We need to know a sub 1, which we can see is 5. However, we also need a sub n, so we need to know the 150th term. Well, in order for us to find that, we have 2 options. We can either take the pattern that we notice and continue it on, or we can create an equation for the sequence and then substitute 150, which will definitely be a lot faster. So let's really quickly make this sequence. Just a general rule of thumb, just a little shortcut. When you're creating an arithmetic sequence, the common difference between your terms will always be the coefficient of n. So I can see that this one is going to be 11n because each time we're adding 11. It's essentially like the slope of your line. So I know that it's going to have the term 11n. However, I know that we have to adjust this to make our first term 5. So if I plug in n equals 1 right here, I'm at 11. So to set it back to 5, I know that we should subtract 6. And this actually is our rule. Now, if you're not comfortable doing this, you can always just use that formula that we just learned. It won't even take that much longer, but this is just something you will come to notice. The common difference is always that coefficient, and then we can just reset by adding or subtracting to adjust for that first term. So now we can find the 150th term much quicker. So if you substitute 150 there, you should get 1,644. Now we have everything that we need to create or to find our sum. So the sum of the first 150 terms is n over 2 times a sub 1 plus a sub n. And then all you have to do is simplify that down, and you should end up with 123,675. There you have it. Okay, go ahead and pause the video and give this problem a try. All right, so here you'll find that the rule for this sequence is just 6n. So then you can find the 120th term, which should be 720, and then you have everything you need. So plug it into your formula, and you should get 43,560. Let's do one more together. This is just to show that it's the same process even if you have a decreasing sequence like we see here. So we are going to need to first create our formula so we can find the 16th term in a more efficient way than just counting until the 16th term. So we want to write a rule first. So I can see that here our common difference is -5. So we know that we're going to have part of our rule say -5n. Now, our first term is 100. So if I plug in 1, I'm at -5. So to get it to 100, I need to add 105. I need to offset it. But once again, if you just use that formula, you will end up with this same exact equation. So now we can find the 16th term here, which ends up being 25. So now we know everything that we need. So to find the sum of the first 16 terms, or the 16th partial sum, just a different way of saying it, we would say 16n, which is our n value, over 2, times a sub 1, which is 100, plus a sub 16, which is 25. And then just simplify that, and you should get 1,000. All right, go ahead and pause the video and give this problem a try. Okay. So here is the equation for our sequence, then allowing you to quickly find the 30th term, and then just plug in your n, a sub 1, and a sub 30, and you should get 1,470. Okay, so now we're going to try an application-based problem. So it's important for you to interpret, like, what are they actually asking you to find. So here it says a small business sells $10,000 worth of their product during its first year. So the sales for year 1 is $10,000. The owner set a goal of increasing annual sales by $7,500 each year for 9 years. So the first thing that's important to recognize is that this is an arithmetic sequence. Each year we are adding the same amount. So that's the first thing to catch. Then they say, assuming that this goal is met, find the total sales during the first 10 years. Now here, it's important to realize that they're actually asking you to find a sum, a 10th partial sum. So I want you to be able to differentiate between the sales during the 10th year alone and the total sales during years 1 through 10. So it's really important to notice they are asking us to find the 10th partial sum. So of course, to do this, we're going to follow that same process that we've been doing. First, we're going to need to write our rule. So I can see that our common difference is 7,500, so that's going to be part of it. But I know that a sub 1, which is right up here, is 10 grand, 10,000. So if my first term should be 10,000 and I'm at 7,500, I know that I need to add 2,500. So that's our rule. But once again, you could always use that formula. So this will allow us to find how much they made in year 10. That's part of our summation formula. So A sub 10 is $77,500. But they are not asking how much did they make in the 10th year. They want the total sales during the first 10 years, so from year 1 to year 10. So now we're going to use our summation formula. So 10 over 2 times A sub 1, which is 10,000, plus A sub n, or A sub 10, which is 77,500. And then just simplify that, and you should end up with 437,500. And of course, we will write our final answer with a $sign in front. All right, here's the last example for today. Go ahead and pause the video and give this a try. Okay, so once again, it's very important to recognize first that this is an arithmetic sequence because you're adding the same amount each year, and that they are actually asking you to find the 10th partial sum, not just how much did they make in the 10th year alone. So here's your sequence, here's how much you make in the 10th year, A sub 10, which is part of the formula. So plug in the rest, and you should end up with $2,500,000. Okay, that is all for today. Thank you so much for watching.